Problem number 61 in our textbook, we have hydrochloric acid 75 milliliters at 0.250 molarity is added to 225 milliliters of 0.0550 molar barium hydroxide solution. And we're asked to find what is the concentration of excess hydrogen ions or hydroxide ions left in the solution after this reaction happens. Okay, so let's first visualize the reaction. We're going to make acid plus base makes water plus a salt, which is going to be barium chloride. And we have to balance this. So there's a 2 that has to go there, and a 2 that has to go here, and we're balanced. Now, what happens is this is a limiting reactant problem. You're given the quantities of both the two reactants. So we're going to have to do the stoichiometry twice and see what we run out of. And then we can determine how much excess of the ions we have. This is just like the excess concentration that we've been doing in class, even when it's not neutralization, when it's just a precipitate reaction. So the first thing to do is to find out the number of moles. So 75 milliliters times 0.25 molar gives us 0.01875 moles. And 225 milliliters times 0.055 molar gives us 0.012375. Now, since I'm not reporting these answers out, I'm not going to round them. I'm going to let their sig figs go until the end of this problem. Okay, so let me just move this up a little bit. And now we're going to just run the stoichiometry, and we're going to find out in moles. I'm not going to go to grams or volume or anything. I'm just going to find out in moles which one makes the most barium chloride. So we'll take 0.01875 moles of HCl, and we're going to make 1 mole of barium chloride for every 2 moles of HCl. And that means that I'm going to make 0.009375 moles of barium chloride if I start with this many moles of the HCl. If I start with the 0.012375 moles of the barium hydroxide, and I have a 1-to-1 ratio in my stoichiometry, 1 mole of barium chloride for every 1 mole of barium hydroxide, I see that I'm going to make 0.012375 moles of barium chloride. So which one is less? This one is a lower amount, so that means that the HCl, this is the limiting reaction here. So the limiting reagent is this one. Now, what that means, if we write the complete ionic reaction, it means that, so I'm going to write this out. We have 2 H pluses plus 2 Cl minuses plus Ba 2 plus, and I'm not putting the states next to them, but we should be putting aqueous next to these, yields 2 H2O liquid plus Ba 2 plus 2 Cl minuses. This is the limiting. That means that whatever amount I had of the H pluses, I'm going to run out of those. So I started with 0.01875 moles of the H plus. I'm going to use them all up. Now I could put the moles of Cl and the moles of Ba2 plus, but it's only asking us about the H plus and the OH minus. So let's look at how many moles of OH minus we have. We had 0.012375 moles of barium hydroxide, but if we have that many moles of barium hydroxide, we have twice that many moles of the hydroxide ions, which is 0.02475. So we have 0.02475 moles of the hydroxide. The barium hydroxide started off with this volume and molarity, which meant that we had this many moles of barium hydroxide. But for every mole of barium hydroxide, we get 2 hydroxides in the solution. So we have 0.02475 moles of hydroxide. Now, the limiting reactant was the hydrogen ions, so we're going to use all of these up. And at the end, we're going to have 0 remaining of the hydrogen ions. We run out. In this stoichiometry, it's 2 hydroxides for every 2 hydrogens. That means that I'm going to use the exact same amount of the hydrogen ions and the hydroxide ions. For every 2 hydrogens, I need 2 hydroxides, so I'm going to use that many. So if I subtract that from the 0.02475, we get 0.006. And that's how many moles of hydroxide are left. But the question is, what's the concentration? So we're going to look at the total volume. We have this many moles of hydroxide in 75 plus 225. So that's 300 milliliters. So we have a concentration of hydroxide is going to be 0.006 moles divided by 0.300 liters. And when you do that, you should get 0.020 moles per liter. Just double check. And sig figs, I think we should have had 3 at the end here. Okay, I dropped one here. This should be 006, and then we can go out 2 more because these 2 places still go. So this should have been 0.00600 for sig figs. And that's the answer to 61.